Hi everybody, in this video we are going to look at this word problem right here where we will be modeling um, a situation where we are removing harmful contaminants from the air, and we want to know about like what rate should this vent hood be pumping out this air to keep the pollutants under a certain percent. So if a vented range hood, so think of that as like above your stove, probably you have like a vent that you can turn on to suck out the heat. You could also have that in, a room where you're maybe working with spray paints, or in a laboratory where you're working with harmful vapors and chemicals and things like that. If a vented range hood removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters per second, then the percent P of contaminants that are also removed from the surrounding air can be modeled by the linear equation P equals 1.06 times F plus 7.18, where F will be between 10 and 75, including 10 and 75, not excluding. Please pay attention to how I just read that. Please don't read it 10 less than equal F less than equal 75. Like, talk like a human for that. Please, please. What flow F to the nearest hundredth, so we're going to round out 2 decimal places, must a range hood have to remove 50% of the contaminants from the air? Now, this is all based on real kind of data. They have a source here and everything where they pulled this stuff from. Now, couple things. The percent P is going to trip up some people. They're going to want to put 0.5, but it says percent P. So percent, like we're going to write 50, not 0.5. All right. And basically all we're going to do is fill in 50 for the P, 1.06 F plus 7.18, and then we're going to solve. If you tried 0.5, you would get a negative number. And this is telling us that our F should end up being a number between 10 and 75. So we can't get a negative, right? So I'm going to subtract 7.18 from both sides. So 50 minus 7 is 43.18. So I'm going to get 42.82 equals 1.06 F. I'm going to divide both sides by 1.06, and I will get F is approximately equal, and I got to round to the nearest hundredth, so that's going to give us 40 if I divide by 1.06, 4, but we need to put 0 here, 40.40 essentially, for F, and that F is in the units liters of air per second. So we would need approximately, I'm just going to rewrite a little bit better, 40.40, that's the approximately equal sign, by the way, liters of air per second to satisfy these conditions. And that's it. That was it for that one. Pretty light. I would say it looked probably like one of the worst ones because it's so wordy, and there's like we're talking about nitrogen dioxide, carbon monoxide, contaminants, blah blah. It's pretty light. Pretty light. Check the playlist if there is something more that you're looking for a practice. If you feel good about being a genius, put a thumbs up. If you have a request, comment, question, you're sad about the math problem, let me know. And that's it for now. Sayonara.